Hi, we're going to talk about InfoCubes in this unit. There are 5 learning goals. 1. To describe what InfoCubes are and their purpose. 2. To distinguish 3 different types of InfoCubes and their usage. 3. To perform data modeling for OLAP systems. And 4. To model master data and InfoCubes using expanded star schema. And finally, to create and configure an InfoCube. Okay, first of all, what is an InfoCube? As described here, an InfoCube is a multi-dimensional data container for reporting and analysis. Okay, so it is the main info provider in BW that contains data in a multi-dimensional format. And it is made of key figures and characteristics, which are all info objects, which are used to create other objects in the data warehouse, including InfoCubes. And also, one InfoCube can have several key figures. Okay, we can keep track of not one but several key figures at the same time, and up to 16 dimensions in an InfoCube. Okay, but 3 of them are used by SAP. So, in fact, a company can define an InfoCube up to 13 dimensions. In other words, we can analyze our key figures in more than one way. Okay, but notice that it is not 13 different ways. Okay, because in the data warehousing industry, a dimension like time is a way to analyze data. Okay, so we analyze data in multiple ways, depending on how many dimensions we have. However, SAP uses a little bit different terminology. To them, one dimension actually represents not one but 248 different ways, represented by 248 characteristics. Okay, in other words, we can analyze key figures. If we have just one dimension, we can analyze the key figures in 248 different ways. Okay, so that's a lot of ways that we can slice and dice data using OLAP analysis. So notice that that's the big difference between SAP and other usage of dimensions in data warehousing. Next, there are 3 basic types of InfoCubes in BW. The first is standard InfoCubes, and they are optimized for reading, okay, to provide data for reporting and analysis. But then we also have the second type called real-time InfoCubes. And this kind of InfoCubes are the basis used for planning purposes, especially for integrated planning, which we'll talk about in a separate chapter. Okay, so this kind of cubes can be used for both reading and writing purposes. Okay, so we can read data from it. We can also write data to it during our planning operation. And finally, there's a third type of InfoCubes called virtual provider. They are known as virtual, which means that they don't physically exist. Okay, so you don't have a physical data store to store data. Okay, instead, data will come as needed when a report is to be produced in real time. Okay, so the virtual provider cannot be used as a data target because we don't physically store data there. but they can be used as an info provider on demand whenever we need to get data from transactional systems to produce a real-time reporting. We can utilize a virtual provider. Okay, next we're going to talk about data modeling issues. First, recall that there are two basic types of systems, OLTP versus OLAP. Okay, now for OLTP systems, data modeling is a well-established process, and there are also various data models that have been developed and widely used in the industry for modeling purposes. Okay, for instance, at the first level, a semantic or conceptual level, the most common data model is ER model, okay, entity relationship model, that some of you probably have learned before. Then at the second level, logical level, the most popular data model is the relational model. Okay, and again, some of you probably have learned it before. Others, even if you have not, you probably used a relational database software package before, such as Microsoft Access or Oracle and so on. Okay, so those products are based on the relational model. Finally, at the physical level, we will then describe the database we want to develop using whatever relational database system that we are using, such as Access or Oracle. They have their own tools for describing the models at the physical level. Okay, so in sum, on the OLTP side, the data models were established and widely used. On the other hand, on the OLAP side, there are a lot of competing data models, but none of them are widely accepted yet. Okay, so there is a big question mark in terms of what kind of data models can we use for OLAP system development. Okay. Now in the book, they describe some kind of bubble diagrams, which are okay, but to me that's kind of rudimentary. So I'm going to talk about another data model and a different approach. Hopefully that will help us better understand the modeling process for OLAP systems. Again, in summary, we have all kinds of data models for both traditional database as well as data warehouse development, and ranging from conceptual semantic models such as ERM to logical model. Again, I mentioned earlier that relational model is used for OLTP systems at the logical level, whereas another model called star schema is normally used for the OLAP system. Okay, so I guess at the logical level, we do have one that is widely used, which is called a star schema, that we will talk about later on. Okay, and then the physical model and so on. But it is at the conceptual level that we are still searching for a widely adopted model when we are developing OLAP systems. But I will talk about one particular model in more detail in the next few slides. What I'm going to be talking about is called a multidimensional ERM, or MERM, which is derived from the traditional ER model. Okay, but now we are trying to develop a model for OLAP systems. Okay, not for OLTP. So it is kind of similar to the traditional ERM, but there are a few new things. Okay, and they are shown at the bottom of the screen. For instance, now you have a fact relationship. You have a dimension field, you have hierarchical relationships and so on. Okay, but we try to keep it simple. So there are really only 5 meta objects as shown at the bottom of the screen. Again, you have a central fact relationship in an MERM model. You have also dimension field, variable or attribute, and then hierarchical relationship and relationship. Okay, so with those 5 objects, we can then construct a MERM model. Okay. So how do we do that from ERM to MERM? Again, notice that ERM is for traditional transactional systems such as OLTP, right? Whereas MERM is concerned with OLAP systems. So the basic idea is to map transaction structures to analytical structures. Okay, so we are moving from OLTP to OLAP systems. And we can do that in a 3-step process. Okay, to move from OLTP model to a OLAP model. Okay, in the first step, you identify business processes. Okay, again, OLTP systems are concerned with transactions or business processes. So you can split your traditional ERM into 1 or more business processes, right? Then in the second step, you will generate fact relationships. Okay, remember earlier mentioned that this is something new in MERM. You have fact relationships as opposed to traditional relationships in the ER model. Okay, and how do we do that? In the description part, it says basically we identify any many-to-many relationship between strong entities. Okay, now to review, in a traditional ER model, we have 3 basic types of relationships. We have one-to-one relationship, we have one-to-many relationships, and we have many-to-many relationships. Okay, so if you consult any basic database textbooks, you will find those 3 basic relationships: one-to-one, one-to-many, and many-to-many relationships. Okay, so now what you want to do is to identify a many-to-many relationship between strong entities. Okay, and because that will give you a fact relationship involving strong entities. And the numerical attributes are candidates for key figures. Okay, so any numbers are candidates for key figures. And then in the third step, you will form dimensions. Okay, so basically you will identify strong entities first, especially those strong entities that are involved in a many-to-many relationship. And then for the rest of the entities, they are summarized into groups that are strongly dominated by other entities. So basically, we have 2 types of entities in an ER model. We have strong entities, and we also have not so strong or weak entities. Okay, and strong entities are those that as the name implies, they can exist on their own. They are pretty strong. Okay, whereas weak entities cannot exist on their own. Okay, so they have to depend, or their existence depends on other entities, strong entities. Okay. Another way to think about weak entities is that weak entities provide further information about strong entities. All right. So strong entities are something that we can easily identify in the real world. Okay, they have attributes that describe them. Okay, and then weak entities are such that they further describe strong entities. All right. Now on the next slide, we're going to see an example, and hopefully that will bring everything together to help you understand strong versus weak entities and fact relationships and so on. Well, actually, not the immediate following slide, but the one that follows. Okay, on the next slide, it is a kind of a summary of multidimensional modeling. Okay, so you define dimensions and assign characteristics to those dimensions. Okay, remember in SAP's world, each dimension is made of many characteristics. Okay, so that is our I guess our final objective. Okay, to define dimensions and assign characteristics to individual dimensions. So how do we get to the goal though? Then first you identify strong entities. Okay, they describe a transaction in the business world, and then the rest of the entities are considered weak because they describe strong entities in more detail. And then I define a dimension for each strong entity, and then so if you have 5 strong entities, you will then have 5 dimensions, and then you assign strong and weak entities to the respective dimensions. All right. Now on the next slide, I'm going to talk about one example. Hopefully, that will bring everything together that we've talked about so far. Okay. Now looking at this model and see if you can identify the entities that are strong versus entities that are weak. Okay. In this model, we have several entities. We have customer, we have material, we have material group, we have salesperson, we have sales department, and finally we have sales transaction at the bottom. Okay. Well, actually, you might be able to tell from the name of the entities. We have one transaction here that is known as what? Well, a business transaction is a sales transaction in this model, right? We're talking about a sales transaction that relates several strong entities. Okay, so each cell, in other words, is related or associated with several strong entities. Now, see if you can then identify the strong entities that are shown in this model. All right. Now, if you recognize that there are 3 entities that are connected to cells directly, then you probably figure out that those 3 are strong entities. Okay. In other words, we have customer connected to cells directly, material connected to cells directly, and so does salesperson. Okay. So these 3 entities are connected to cells directly, and therefore they are strong entities. All right. Now, actually, I probably have jumped ahead myself a little bit. We should have, talked about the many-to-many relationship first. For instance, if you consider the relationship between customer and material. Okay. Now here we are talking about customer and the products that they purchase. Okay. Remember that the products that we sell are also known as a material in SAP. Okay. So ask yourself the question: what is the relationship between customer and material? Okay. Let's say you go shopping, a Target or Walmart or your favorite store, whatever, Amazon, any product that you buy or any product that they have for sale there has a relationship with their customer, right? And my question is the relationship between customer and product or material, is that a one-to-one relationship or one-to-many relationship or a many-to-many relationship? Okay, again, think about the product that you last bought from Walmart, for instance. Okay, whether it's some kind of toy or milk, some kind of fruits, whatever that you buy. If you look at the receipt that you get on your way out, okay, after you check out, the items that are recorded on your receipt have a many-to-many relationship with the customers, okay? Because anybody can go into the store and buy, a gallon of milk, for instance, okay? So one customer can buy milk, and another customer can buy the same milk. I mean, not physically the same, but the same type of milk, okay? So many customers can buy the same product, and at the same time, the same product can be sold to many different customers. Okay, so they have a many-to-many relationship, in other words. Okay, one customer can buy many products. You can buy milk, and you can buy pizza, you can buy bananas, you can buy toy, you can buy gardening tools, whatever. Okay, so you can buy a lot of products, and at the same time, each product can be sold to many different customers. So we have a many-to-many relationship, and therefore we can turn that into a fact relationship to connect customer and material, indirectly through the sales transaction. Okay, so we basically converted the many-to-many relationship between customer and material into a one-to-many relationship between material and sales, and one-to-many relationship between customer and sales. Okay, so at the bottom of the screen, the cross feed that you see, that represents a one-to-many relationship. Okay, one customer can buy many products, and at the same time, each product or each material can appear many times in a sales transaction. Okay. Similarly, you have a many-to-many relationship between salespersons and material. Okay, here we're talking about maybe a service industry, a car dealership, and so on. Okay, when you go in to buy a car or for a service, they have people handling your requests. So that's also a many-to-many relationship between salesperson and the material, and salesperson and customer, and so on. All right. Again, we change that into a one-to-many relationship between salesperson and sales. Okay. So again, important point here. We have three strong entities: customer, material, and salesperson. Okay. Now, how about the other two entities? Material group. As you can see there, material group really further provides information about material. Okay, it describes what kind of material you have in terms of different material groups or product groups. Okay, how do you classify your materials or products? So you describe that in the material group entity. Similarly, for each salesperson, we have additional information about them. So we have that information or data in a sales department entity. Okay, so sales department is a weak entity, but also notice that it has a one-to-many relationship between sales department and salesperson as well. Okay. So review this model carefully, and then hopefully you can better understand what we have talked about so far in multidimensional modeling. Strong versus weak entities, many-to-many relationships, business transactions, and so on. Okay. Finally, the last slide for this section here is to form dimensions as we complete the model. Basically, we may have additional weak entities. For instance, if you look at the model at the bottom there, for the customer entity, customer dimension, I should say. Okay, so we mentioned earlier that customer is a strong entity, so we use that to form a customer dimension. All right, and then in this dimension you have customer name, city, region, and so on. Okay, and where do those come from? They come from weak entities further up. Okay, so again, if you have additional entities that further describe your strong entities, they should belong together in the same dimension. So now you have one dimension for customer, one dimension for material, another dimension for sales people or sales organization, and then finally another dimension is time dimension, which we have not talked about, but is pretty common in data warehouse. Okay, we need to have a time aspect to all our data in a data warehouse. So we'll talk more about that in the future. Okay, but also review this slide carefully to make sure you understand that again, additional weak entities are assigned to the dimension where they are related to the strong entity in the corresponding dimension. Okay. Okay, a review questions about real-time queues that we talked about earlier. Another question about MERM.